welcome to week 5 in geometry. This is the week of September 30th, where assignments will all be due on September 19th. Please make sure you've got your math notebook out at this time and that you're ready to take great notes as you watch this recording. This is a recording. So, make sure that you are taking advantage of the fact that you have the ability to click pause as you watch this recording so that you can take good notes. Remember, an active learner is somebody who's taking notes while they're watching. They're interacting more with this recording. They're going to get more out of it. If you're passive, you're not going to get much out of this, and it's kind of a waste of your time. So let's make the most out of your time and be active in taking notes. And you'll find that as you're completing this week's assignments, you can refer back to your notes and things are going to be a lot more easy. So I've got a warm-up question for you where I've got two parallel lines cut by a transversal. And I've given you the angle measurement of angle E and D. And I want you to use what you know about angle pairs to solve for x. So use what you know about angle pairs to set up an equation that allows you to solve for x. So when you're completing this, keep in mind that you do need to identify what type of angle pair this is, and then that will allow you to write the equation to solve for x. So at this time, I want you to go ahead and click on pause and try this on your own, and then when you're ready to check your work with mine, go ahead and click play again. All right, so let's first go ahead and find where the angles are on the figure. So angle E I've highlighted, and then angle D I've highlighted. So what kind of angles are these? What kind of angles are these? These are called, first of all, we know they're on the inside of our two parallel lines. So if we kind of focus on our two parallel lines, I'm going to go highlight those for you. Our two parallel lines, they're on the interior. So we know that these are going to be called interior angles of some sort. And then let's look at our angles. Now, in relation to our transversal line, remember our transversal is this line here. It's the line that intersects your two parallel lines. So our angles are alternating. They're on one side of the transversal and on the other side. So we would call these alternating. They're not on the same side. The same side would be like D and F. They're alternating. They're on different sides of the transversal, so we call those alternating. So the first word describes where they are, the angles where they are in relation to the two parallel lines. The second term we use, alternate interior angles. Whoops. So the first term, alternate, describes where the angles are in relation to the transversal. That second, interior, describes where they are in relationship to the two parallel lines. So these are alternate interior angles. And what do we know about alternate interior angles? We know that they are congruent. They're going to have the same angle measurement. So because they're alternate interior angles, we know they're congruent. So we would know then that angle E is going to be congruent or equal, we can go ahead and say, the measurement of angle D. So now let's substitute in what we are given. We know that angle E is represented by 6x minus 1. We're going to set that equal to what's represented by angle D, which is 3x plus 5. And now we're going to go ahead and solve for x. To solve for x, I want to get all my x's on one side of the equation and all my constant terms on the other. So I'm going to start by subtracting 3x from each side. That'll give me 3x minus 1 equals 5. Then I'm going to add 1 to each side. That gives me 3x equals 6. My last step would be to divide each side by 3. And that gives us our answer. 6 divided by 3 is 2. So x equals 2. x equals 2. You can always check your work by plugging that in to each equation. They should then be equal. All right, so this week you will have a chance to, I'm going to kind of skip down to one of your assignments this week, to review the different angle pairs that we learned about in Unit 1 by completing a project where you're going to draw in some roads going north and south and east and west, and when you do that, you're going to create some parallel lines and transversals, and you're going to be then showing me all the different types of angle pairs. We're also going to be looking at Unit 1 Session 7 on inductive and deductive reasoning, and Unit 1 Session 8 on proofs. There's also a built-in catch-up day. So just some reminders, some helpful reminders. Make sure you're redoing anything in Unit 1 with low scores. Remember, once we are done with Unit 1, you will not be able to redo any assignments. And we are quickly approaching that deadline. Next week, we will be taking the Unit 1 test. So just a heads up about that. So you can start reviewing, and just know that next week, not this week, but next week will be your last opportunity to redo low scoring assignments in Unit 1. Then don't forget to send me a message to let me know if you've redone any assignments or submitted any late work. All right, so what are we doing in Unit 1, Session 7? Unit 1, Session 7, we are focusing on inductive reasoning and deductive reasoning. So what is the difference? So first, let's talk about the difference. So inductive reasoning is when you make conclusions based off patterns you observe. So you observe something, and then you are able to classify some different patterns that you're seeing based on your observations, and from those patterns you would make conclusions. That's what inductive reasoning is. The conclusion you would reach is called your conjecture, where deductive reasoning is a conclusion arrived from looking at facts, definition, rules, and properties. And the conclusions based from deductive reasoning is always true, where it might not always be true with inductive. So let's see here an example of inductive reasoning. So look careful at the figures below, and then use inductive reasoning to make a conjecture about the next figure in the pattern. So first of all, what do you see? What is the pattern with the shaded triangle? So it looks like the pattern is that it keeps moving clockwise around our figure. So it seems like it's moving clockwise and stays on the outside of our figure. So that would be the pattern. I would say that it's moving clockwise and it's staying on the outside. The triangle is shaded, it's on the outside. So our next figure would probably look, would have, I'm not even going to do a new one. It would be, if we were to redraw, it would be this triangle that would be shaded in. So you're going to get practice, you're going to get to do that. Oh, here it is. That is what the next shaded area would be in that figure. We can also use inductive reasoning and patterns with numbers. We can do it with numbers. So here, what do you notice about the products every time? So let's go ahead and do the multiplication. What's 4 times -2? -8. What's 3 times -7? -21. What's 1 times -9? It's -9. So what do we notice about all the products? And the product is what you get when you multiply two numbers together. Well, I notice that I have a negative number every time. And what two numbers, what do you notice about the two numbers that we multiplied? Was it a positive and a negative, wasn't it? We multiplied a positive and a negative. And every time we multiplied a positive and a negative, we got a negative answer. So that is what our conjecture could be. So based on the pattern that we saw when we multiplied a positive times a negative, so every time we took a positive and multiplied it times a negative, we always got a negative answer. That was our pattern. So our conjecture can be that rule, that when we multiply a negative times a positive, we always get a negative. So let's take this a step further and see if we can find a pattern between each term and the value it gives us to come up with a rule, that relates the term to the value. So again, we're trying to come up with a rule, which is going to be an equation, that relates the term to our value. So, to set up an equation that relates the term to the value, and I'm going to go ahead and say that the term will represent with an x value and the value will represent with the y. So, to do this, we want to find out first, going between value to value, what is happening. So, from 5 to 8. Looks like we're increasing by 3. From 8 to 11, we're increasing by 3. From 11 to 14, we're increasing by 3. So it looks like from each of our values, we increase by 3. So what that means is that we're taking 3 times, and you know what, I think in our, you guys have in the lessons, it's the term is represented by n. N represents the term. So I'm going to say 3n. So that would be our rule, is that we're increasing by 3 each time. So now let's check our equation that we have. So if for the first term, the corresponding value of our first term is 5. So does that rule work? If we were to take 1 and let that represent n for our first term, what do we get? We just get 3. So we need to do some adjusting here. We're at 3, but we need to get to a value of 5. So it looks like we would have to increase that rule. We would need to add 2 to that rule. So what I did is I took 3n and I added 2 to the rule. So I've adjusted the rules because 3 times 1 would give me 3, and then I would add 2 to it to get that value of 5. So that's for our first term. Let's see if this new rule that we've established would work for our second term. So the second term says that the corresponding value is 8. So the n, remember n represents the term number. So if we're going to use this pattern that we've started to create down here, we would for the second term. So for our second term, to test it, we would say 3 times 2 plus 2. And what does that give us? 3 times 2 is 6. 6 plus 2 is 8. That is working. That worked for this column. The second term should give us 8. What about the third term? Let's try it and see if this pattern is working. So we would take 3 times 3. 3 represents our third term. And then plus 2. 3 times 3 is 9. 9 plus 2 is 11. It worked. So the rule that is going to work here is going to be 3 times the term number, n, and then we have to add 2 to that. That would be our rule. So again, how we did that was we first figured out how is our value increasing each time. It's increasing by 3. It's increasing the same amount every time. So that means it's going up 3 times n. So we put 3n there. We plugged in the first term and the corresponding value and realized that we had to adjust to get to that 5 by adding 2 in there. So that's where we got the 2 from our rule. Here's another problem for you where you need to find the rule for the nth term. So you've got the term number and the corresponding value, and we'll let n represent the term number. And go ahead and see if you can write an equation using this same pattern that we did up above. So go ahead and click on pause and see if you can come up with a pattern. And then check your work with mine. All right, so the first thing I want to do is see how much we're increasing from from value to value. So from 1 to 3, we're increasing by 2. From 3 to 5, we're going up by 2 again. And from 5 to 7, we're increasing by 2 again. So we know the start of our equation is just going to be 2 times n. So now we want to see if that works. So let's test that for our first term and see if that works. If we plug in 1 for our first term, we would have 2 times 1. And remember, and that would give us 2. But that's not what the corresponding value needs to be. The corresponding value for term 1 needs to be 1. So how can we get from 2 to 1? We can make an adjustment. We can subtract 1, and that would give us the 1. So now it looks like our rule might be 2n minus 1. So I've adjusted our rule, so it's 2n minus 1. So now let's check it for our second term and see if it works. So the second term, I'm going to plug in 2 for n and subtract 1 from that. Let's see if that works. 2 times 2 is 4. 4 minus 1 is 3. Oh, that works because the second term, the corresponding number needs to be 3. Let's check it for a third term and see if it works. So our rule so far is 2n minus 1. We're working on our third term. So I plug in 3 for n. 6 minus 1 equals 5. So that worked. So that is the correct rule. So you're going to get to do that this week as you work through Unit 1, Session 7. One more that I wanted to show you, and how would we find the rule for the nth term with this pattern? So what first we want to start and see if we can figure out if we're increasing the same amount from our values. So from 3 to 8, we're going plus 5. From 8 to 15, we're going plus 7. And from 15 to 24, we're going plus 9. So this is a little different. We're not increasing by the same amount each time. So how are we going to find the rule for the nth term here? So because the amount increasing from our value to the value is not increasing by the same amount each time, we would say that this is an example of not a non-linear pattern. It does not increase the same amount every time like we saw with our previous two examples. Since in these examples, the amount that we were increasing each time from value to value for each term was increasing the same amount every time. So we would say that these examples had linear growth. They showed a linear pattern, linear growth. They went up the same amount every time, so it was linear. Just like our second example, it was also an example of linear growth because it increased by 2 every time. So now in this example, we're seeing that we don't have linear growth. It does not go up the same amount every time. So we are going to go about finding the rule a little differently now. So I'm going to go ahead and erase this part because we just proved it was nonlinear. So since it's nonlinear, we're going to solve and find the rule, we're finding the rule pattern a little bit differently. So what we're going to do now is we're going to find factors of each of the values. So when I say factors, what are factors of 3? Well, 1 times 3 is 3. That's the only factor. What about 8? Well, I know 1 times 8, and then I know 2 times 4 also gives me 8. What about 15? 1 times 15, we've got 3 times 5, and I think that does it for 15. For 24, we've got 1 times 24, I've got 2 times 12, and I've got 3 times 8, and I've got 4 times 6. Those are all my factors. So now what we want to do is see if we can find a pattern between our factors. So I'm going to help you guys out here. I'm going to circle some factors. Now, what we want to do is see if we can find a pattern between the term number and the factor. So we want to see, so the pattern that I found between the factors that I circled is that if you look here, from 1 to 3 we add 1 plus 2 would give us 3. So we're adding to our first factor 2, and then we get our second factor. Same here, if we add 2 to our first factor, we get 4. If we add 2 to our first factor, we get 5. If we add 2 to our first factor, we get 6. So these are the factors that have a pattern. So now we have to look a little bit closer to actually come up with the pattern that's going to relate the term to the value. So what we do is we want to, I'm going to get rid of, well, I'm going to keep those actually. Let's change here. So we want to see what is the pattern between our term number and our first factor. So what is the pattern between our term number and the first factor? What are you seeing between the term number and our first factor of each term? Do you see a pattern between the term number and the first factor? Well, it looks like the term number is the same as our first factor. So I'm going to represent that by saying n, because remember we always use n to represent our term number. We always use n. So n is going to represent the factor, our first factor. Now we need to find a relationship between our term and our second factor. So our term and our second factor. So how do we get from 1 to 2? Well, we can say plus 2, right? Because 1 plus 2 would give us 3. So if we add 2 to our term, we get our second factor. Let's see if that works for all of our terms and our factors. So if we add 2 to the term number, do we get the factor, our second factor? 2 plus 2 gives us 4, so that works. Let's see if this pattern continues where we're relating our term to our second factor. 2 plus 3 would give us 5. For our fourth term, if we add 2 to it, 2 plus 4 would give us 6, so it works. So what we did to relate our term to our second factor was we added our term plus 2. So again, just to kind of sum up what we did here is first, we wanted to have a pattern between our term and our first factor. And we saw that in this case, it was just that the term was the same as our value. So we put that right here. Then we need to do that again. We need to find a pattern between our term and our second factor. And we put that right here. So now let's test. Let's test our rule that we've come up with. So let's test it. For the first term, our term value, n, would equal 1. So I'm going to plug in 1 wherever I see an n. So I'd have 1 times 1 plus 2. And that should give us the corresponding value of 3. So remember, we're trying to find a pattern that relates the term to the value. So let's do it. Do the math. Do what's in the parentheses first. 2 plus 1 is 3. 3 times 1 is 3. So it works for our first term. Let's keep it going and make sure it works for our second term. The second term, the n would be 2. So anytime we see an n, we would plug in 2. So 2 plus 2 in the parentheses gives us 4. 4 times 2 gives us 8. So it works. It works. For the third term, we'll check that really quick. Our third term, n is going to equal 3. 3 plus 2 is 5. 5 times 3 is 15. So the rule is going to be n times n plus 2. And that is how you find the pattern when you have a non-linear pattern. That's how you find the rule when you have a non-linear pattern. So again, always check first to see what kind of pattern do you have. Do you have a linear pattern where you're increasing the same amount each time between the values? You increase the same amount each time, which makes it linear. Or are you increasing not the same amount each time, which would give you a non-linear pattern, which means it's a little tougher to find that rule, but you can do it. First you find the factors, then you find the pattern between the term number and each factor. All right. So that's a wrap. It's time for your key phrase assignment. Let me get that in here. So first and foremost, we are completing the key phrase assignment for the week of September 13th. Make sure the date of the key phrase assignment links up with the date of this recording. Both should read September 13th. So I've got a table below where we've got the term and the value, and I want you to decide if this shows a linear, if the pattern, that should say pattern, I'm missing the N there, is the pattern below linear or non-linear, and how do you know? So the directions to complete the key phrase assignment are below in case you need a reminder. If you need any help with this week's assignments, let me know, and have a great rest of your week.